Hello and welcome. In this video we will be looking at how to make a movie in PyMOL 3 using molecular dynamics trajectory. By the end of this tutorial you'll be able to load trajectories or multi-state objects into PyMOL 3, add multi-state objects to the timeline using programs and state subtracts, use object copies to layer representations, and create a multi-track movie with programs, views, scenes and transformations. Let's get started. We're going to begin by importing a trajectory, the output of a molecular dynamics or MD simulation, and this was set up and run in Maestro. We can bring MD trajectories into PyMOL in a number of ways. If viewing the results in Desmond or FEP plus results in Maestro, we can use Maestro's Send to PyMOL feature. We came across this feature in earlier video tutorials when we saved a number of scenes in Maestro and then used the Send to PyMOL dialog to create a simple scenes-based movie in PyMOL, so check out those videos if you need a recap. The Send to PyMOL dialog also has the option to include trajectories, so we can select what we want to send from the workspace or project table, check the trajectory box, and here is our trajectory in PyMOL, with matching styling and representations. We can also load trajectories directly into PyMOL, and I'm going to do this now by loading in the 4PUZ FEP trajectory.cms file from the PyMOL 3 course data directory, so feel free to follow along. To learn more about the relative binding free energy perturbation or FEP plus workflow and the SYK protein structure and ligand that we're looking at here, check out the free energy calculations for drug design with FEP plus Schrödinger online certification course. The purple and green spheres here are sodium and chloride ions, and we can select quickly using the segment selection mode and either create a new selection and hide them or just fully remove them, since although they were important to include in the MD simulation, we're just going to focus on the protein, ligand and the water molecules in this movie. Let's generate a selection for the water molecules and the ligand, and we can easily style these differently if we want. We can see that there are also some small molecules near the ends of the protein chains, and these are where we capped the ends of the chains, or the termini, for the molecular dynamics simulation, so I'm going to delete or hide these two. I'm going to change the ligand colour so it stands out a bit more. For simplicity, and if you'd rather skip these selections and deletion steps, you're welcome to load in the pre-generated 4PUZ FEP trajectory selections session file from the PyMOL 3 course data directory. Click on the timeline icon below the contents panel to open the timeline. In the previous video, we looked at how to quickly add all of the states in a multi-state object to the timeline using the player's movie option. We can also do this by clicking Add Track, choosing our 4PUZ object, and then right-clicking on the object track and choosing Store Program, and then we can use either the State Sweep or the State Loop program. With both of these programs, we can do things like bring in a certain range of frames, and then have the program loop through or sweep up and down through all of the states in that range that we set, as many times as we define, over a certain number of seconds. Now let's add a state subtract. In the timeline inspector to the right, we can watch the number in the state subtract slider to get a feel for what both the loop and the sweep programs are doing. And remember, we can right-click and edit a program if we want to update it. As well as storing multi-state objects to the timeline via programs, we can use the timeline inspector state subtract slider to scrub through the states and then click on the keyframe icon to save individual states. And just like adding other kinds of keyframes to the timeline, we can right-click anywhere on the timeline and choose Store. And Store State lets us choose a specific state number here. If we store two different states, this will be treated as a range, and we can see that all of the states in between will be included. As with all other keyframes and stored programs on the timeline, we can easily right-click to delete or use the keyboard delete key to get rid of anything we don't want to keep on the timeline. And if we click and drag, we can use the lasso to select multiple keyframes and move or delete them all at once. Now that we know we can add just specific parts of a molecular dynamics trajectory to the timeline, let's go ahead and add just 20 of our frames from this trajectory. I'm going to add keyframes for state 1 and for state 20 at the start and end of our 5-second timeline. Make a note if you choose different parameters here, and don't forget to save your session, as we're going to be making some edits. Our MD trajectory movie is looking pretty nice, but you might be wondering how we can use some of the object-specific settings to do things like alter the transparency between representations. We could add some settings subtracts for our existing 4PUZ object, such as sphere transparency or cartoon transparency, and this will work well if we use different representations for each of our different selections. What if we wanted both the waters and the ligand represented as spheres here though? This would mean that we can only alter the transparency for all spheres at once, regardless of selection. This is where creating a copy of a selection in the form of a new object can be really useful. In the Actions submenu next to our ligand, choose Copy to Object. I'm going to rename this new object Ligand Copy. Now that we have a new object, let's add it as a new object-specific track in the timeline. And let's add a state subtrack. We need to be sure to add the same range of states with the same placement and duration as our original 4PUZ object to be sure that everything stays in sync. Looking good! Now we can do something like have just our water selection in our 4PUZ object using the spheres representation. And we can alter the transparency here. And now we can add additional settings subtracts here. And then we can have the sphere transparency fade differently for our ligand copy. Looking good. And then I'm going to save my session again. Based on what we've already worked through in previous video tutorials that feature the PyMOL 3 timeline, let's use some programs, scenes, and views to create a compelling movie. You're welcome to get creative here, and you don't need to recreate what I'm doing, but have a go at using a number of different tracks and subtracks. I'm going to start off by updating the colours and saving a scene with a nice zoomed out view of the system. And let's store some camera views and maybe a new take or roll program to show off more of the structure as we zoom in. I'm going to update the ligand copy transparency here so the spheres become more visible throughout the new take program. Next, I'm going to create a new object, which is a copy of just the protein chain, so we can put a nice surface on here without it including other parts of the 4PUZ structure. And check out the video transcript and the PyMOL command reference to learn more about the ramp new command. This is a really fun way to use a spectrum to colour by proximity. I'm using the measure wizard to figure out the range here, as in this case the protein surface within 5 angstroms of the ligand will be coloured purple, and anything 34 angstroms or more away from the ligand will be coloured red. Looking good! Now I'm going to edit and increase the duration of this movie to 10 seconds so that we can show off this surface a bit. And with the new timeline length, I'm going to update all of the state subtracks to actually just use the whole MD trajectory. So frame 1 to frame 85 at either end of the timeline. Make sure that the new object has a state subtract and that all of the states match over the course of the timeline so that everything is in sync. Checking the values in the timeline inspector for each of the object's state subtracts can be really handy here. I'm going to add in a transparency track for this surface and do full transparency for the first part of the movie, then store a new scene without the waters and in fact the entire 4PUZ object disabled in the contents panel. So this scene contains just the ligand copy and the protein copy object. I'm storing that second scene to the timeline and adding a surface transparency keyframe so the surface is fully opaque at the end. And let's do a roll program here so that we can really highlight the proximity coloring as the surface becomes more visible. I'm making sure to update views and scenes as needed, and I'm going to check and update my clipping plane so that we can see all of the structure throughout the whole roll rotation here. And I'm pretty happy with this. Heads up that this was at least an hour's worth of editing in PyMOL, so just be aware that if you are adding lots of tracks and lots of surfaces and transparency fades, you may need to have some patience. Clicking through the timeline at different timestamps to inspect the different views and values in the timeline inspector can be quicker than hitting the play button here. Okay, I think I'm done. Time to export. We've looked at how to export movies in several of the previous movie creation video tutorials, but remember it's always good practice to render in draw mode first. And this looks good, but I'm going to quickly edit the stick H scale so that the ligand hydrogens are the same radius as the rest of the ligand atoms within the stick representation. And if you're planning to render in ray mode, be sure to test out the ray trace modes and lighting settings. I'm going to test the rubber preset in the lighting settings plugin, and do some static ray trace tests to check everything's looking good before spending the time and processing power ray tracing this full movie. I don't love how the semi-transparent spheres look with this lighting, so I'm going to revert back to the default lighting. I'm also going to edit the interpolation types between the scenes and views, so we can do things like ease in and ease out, or keep the view constant. I'm once again going to use the 1920 width and 1080 height, and the FFmpeg encoder and MP4 file type. A reminder too that when using the FFmpeg encoder you may need to follow the install instructions if you're using a new version of PyMOL for the first time. And here's the result of that export with ray traced rendering. That brings us to the end of this tutorial. You can now load trajectories, multi-state objects, into PyMOL, add multi-state objects to the timeline using programs and state subtracks, use object copies to layer representations, and create a multi-track movie with programs, views, scenes, and transformations. Thanks for watching.